So without too much torture, we would expect integration of vector valued functions to be just as nice as all that time and trouble we went through to show that differentiation as well as derivative rules like the product rule are still valid. So since we've done this fairly reasonably well.
You've been a very good boy.
Why, thank you. We will give a little break here and say, you know, vector valued functions integrals do just like you expect, since since integration is itself a linear, then the integral of a sum equals the sum of the integrals, right? And that gives us this property in a logical way that the integral of a vector valued function, let's call this, let's say r of t was f of ti plus g of t j plus h of t k. The integral of that is the integral of the I part times I plus the integral of the j part times j plus the integral of the k part times k. So what could be better than that? And of course, if it's a definite integral, then we get the same result. So let's just do an example to show how that works. So we'll integrate the following vector valued function. It's integrating ln of ti plus 1 over tj plus k dt. So integrating ln of t, okay, you have to do a little bit of extra work on that if you think about it. You have to say something like let u equal, try again, let u equal ln of t and dv equal, oh sorry, didn't mean to type some of that stuff there that I didn't mean to type. Oh, let me get out of this mess. Let's just start deleting here for a bit, and don't want to delete too much. Well, all right. ln of t, there's u, and I was going to type a comma there, but I realized I can't do that because it'll interpret the comma otherwise. dv is equal to dt. And you might say, where are we going with this? Well, because du, this is refreshing integration by parts, du is equal to dt over t, and v is just equal to t. And so when you integrate u dv, which is integrating ln of t, you get uv, that's t times the ln of t, minus v integral of v du, well, that's just the integral of dt, because this t and this t would cancel out. So therefore, the integral of dt is just t. It's like 1 times dt, so the integral is t. The negative sign is from the formula. The negative sign right here is from the formula for integration by parts, and then plus some arbitrary constant. Okay. And so, and this one's easy. Integral of 1 over t is ln of t, and integral of 1 is t. And so our answer is this vector value function, t ln of t minus t times I, that's from all this, plus ln of t times j plus t times k, and then notice plus c, and I put the vector symbol over the t. Wish I could remember how I typed that. I put the vector symbol over the t, and I did that to show that there's actually a constant vector, which is a constant, this c1 times I, plus the constant I got from this integration times j plus the constant I got from this integration. So there's a constant times I. This c is actually constant times I plus some constant times j plus some constant times k. And so here's a definite integral, and there's no j term in this one, so we just evaluate this one. Well, integral of e of t is e of t, and the integral of t times e of t, again using integration by parts with u equal to t, dv equal to e to the t dt, and then for what's worth, du equals dt and v equals e to the t. So we're going to get uv, which is t times e to the t, minus integral of edu, which is minus e to the t. Caution, remember this is plus some constant of integration, and so no, it's not plus some constant of integration because I have a definite integral here, so duh. So when I evaluate, when I put in 3, this is e to the third, and when I put in 0, minus 1 times I, so there's that part. That part was the easy part. This, the integral of the t e to the t k part, well, the integral of t e to the t is t e to the t minus e to the t, so when we put in a 3, we get, this is actually 3 e to the t minus e to the t, 3 e to the 3 minus e to the 3, so 2 e to the 3. And then when we put in 0, we have 0 minus e to the 0, which is 1. But since it's minus a negative, it winds up being plus 1. So this is our vector valued function, which is the definite integral of this vector valued function. Okay? Evaluated at 0, evaluated at 3, subtracted.